Hello everyone. Today we are going to see the working of the 74HC595 shift register. In the previous two videos you had actually seen how it works, what binary is, how to convert decimal to binary, binary to decimal and all stuff like that. Today we are going to see it in working. Let me just show you something. I have got uh, a bunch of 8 LEDs and I am going to make them switch on or off. Let me just start the simulation and just show you what is the output going to be. The output is that one of these is on, this next is off, the next one is on, next is off, and so on and so forth. Let me just show you a little bit of the code where I'm actually controlling these. So this is the part where it actually controls. So 10101010 actually means that one LED is on, second is off, one is on, second is off, and so on. Suppose I change this to 11110011. So you can see how things will happen. I'll just run it again and you will see that it is now showing 111100 and 11. So the display actually happens according to serial data, serial bits which are present in a particular variable. We'll do all this in detail, but I just want you to see how we can do. So 10011001. Okay, again 8 bits. So let me run this. So now it is 10011001. This is how it displays. Let us see the IC first. The IC has 16 pins and pin number 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, and 16. Let us see the simplest connections first. This is the power on and I have connected it to power. This is the power rail which is actually connected to this power rail which is actually connected to 5 volts DC on the Arduino. The ground is connected to the ground rail which is again connected to the second ground rail over here. So I'm going to use both the rails now. Next, the simpler connections are basically pin number 15, which is the output 1. That is the parallel output. Okay, so parallel output. You can see that I have connected eight of these LEDs over here, and this is LED number 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I have connected the anode of the first LED to pin number 15, which is the output 1. And you can see this is pin number 15 is output 1 of the parallel output, and output 2 is actually pin number 1 of the IC, and 2, 3, 4, 5, 6, 7. So this becomes output 8. So this pin number 15 is output 1 and 2, 3, 4, 5, 6, 7, 8. So I need 8 outputs. These are the 8 outputs. And each of them are actually connected to one of the anodes of each of the LEDs. The cathodes, I have actually connected all the cathodes using this wire from here to here, and using this particular resistor, which is a 100 ohm resistor, I have connected it to the ground rail. You can see the ground rail is connected. So this should be, I think, should be clear to you that all the output pins are connected to each one of the anodes of the LEDs, and the cathodes are connected together through the resistor. It is connected to the ground. Now this part done, we have taken care of all these on this side, and we have we have taken care of these two pins on the top. Now the next pin, we'll go from the bottom. We will not connect this inverted output 8. This is basically pin number 9, which is used to connect to the next 74HC595 IC if we need to have a daisy chain kind of a system. So we are not connecting. You can see that I have not connected this pin to anywhere. I'm only concerned with 1 byte, so that 1 byte is taken care of here. Next is shift register clear. This is memory reset. We need to connect it to positive, and this is output enable. We need to connect it to negative. So if we connect output enable to positive, output will not be enabled. I'll show it to you in a little while. Similarly, memory reset, we use this only when we need to reset. The next two very important pins are basically the output register clock and the shift register clock. Shift register clock is basically used to line up your cars into that lineup area. So they are not started racing yet. I am referring to the cars analogy that we did in the previous video. This output is basically the latch pin. So this basically controls the latch. Okay. So this basically controls the shifting of the clock register to the storage register. We'll see this in a bit little. Yes, one very important, the input. The input which is actually coming from the Arduino. So input is basically connected to pin number 2. The latch is connected to pin number 3 and the clock is connected to pin number 4. These are the only pins that are basically connected to the Arduino. So to use these 8 LEDs, I do not need 8 pins from the Arduino. I basically need only 3 pins. Out of this, 2 are basically used to control, then 1 is basically used to send the data to the IC. Okay, now this part done. We know 2, 3, 4. We need to learn about this or remember this. Okay, let us see the code. In the code, you can see we have a data pin variable which has a value of 2. So latch pin is again a const variable which is having a value of 3 and clock pin which is value of 4. All the 3 pins have been selected as output mode. All of them are actually giving output to the IC. Now, very important. I have written just a few lines here. The first line basically creates a variable of byte data type. And that byte data type is starting with a 0p, indicating that whatever I am writing here are actually uh, are actually bits. This is 1 byte. This is okay. So what I will do here is create my own design. So if I want all of them to be on 1 1 1 1 1 1 1 1, so all of them will be on. Okay, so okay, this is what will be displayed. Now, how are we going to display it? We are going to digital write on the latch pin low. Why low? Because I want the data to remain in the shift register till I make it high. So when I make latch pin high, it will be actually shifted from the shift register to the storage register. This is basically to let the data remain in the shift register. How do we send the data to the clock register, to the shift register? So how do we send it? We send it using a command called shift out. Shift out is an inbuilt command for an Arduino, and what we supply there is the data pin number. So data pin actually has a value of 2, clock pin number which has a value of 4. Okay, and we are writing MSB first. I'll discuss MSB first a little later, so don't worry about it. And what I want to display. So basically, we tell what is my data pin, what is my clock pin, whether I want the uh, most significant bit going in first or least significant bit going in first, or so that means here you can supply either LSB first or MSB first. I'm writing MSB first at the moment, so let's see what it does. So LEDs is basically what is going to be actually output to the shift register. So this is what is going to be output. So that means the shift register now is going to get all the ones. So so that means now when it sends all the ones to the shift register, that means all the pins of all the output pins are going to get ones. That means they are going to get highs. So the get highs means they are going to get high. The output is going to go high, and all the LEDs will display. All right. The display will not happen till I say latch pin make latch pin as high. So the moment I make latch pin as high, the data is now shifted from the shift register to the latch register. Then it is actually given to as output uh, to the LEDs. Let us now display. Now, as I have put all of them as one, so it should actually display all of them. All the LEDs should switch on. So all of them, all the LEDs are switched on. Let me switch this off. I am making this as a remark. So latch pin has not become high. So when I say latch pin is not high, what do you think is going to happen? Is the data not going to get shifted into the shift register? Yes, it is going to get shifted into the shift register, but they are not going to go into the storage registers. So the LEDs are not going to glow. So I have started the simulation. LEDs are not glowing. Why are they not glowing? Is because we have not uh, sent a high to the latch pin. So when I don't send a high to a latch pin, what happens? The display doesn't happen. The pins are not giving output, although they are storing something somewhere in the shift register, yes, but because the shift has not happened from the shift register to the storage register, or what we call as the latch register, so no output is going to come. All right, let me stop the simulation and let me start the uncomment this and let us run this again. So that's it. Stop it again. Let me give some other pattern. So 1101 1101. Okay, so there are two zeros somewhere. So the output is 1101 1101. So this is the number that we were actually going to display. What is the most significant bit? Most significant bit is the last one over here, the first one on the left hand side. So most significant bit has actually gone in first. And let me show you. When we say MSB first, out 8 gets the most significant bit. So if I write MSB first, out 8, out 8 means the output 8, this one, is actually going to get the most significant bit. Alright. Alright, let me change this to something which is easily discernible. So I'll write 11110000. So I know that there is a 0 on the least significant bit and there is a 1 on the most significant bit. Let's run this now. So when I run this, you see that because we had written MSB first. So the most significant bit is actually received by the output 8. So output 8 will that naturally that is going to go first. So that is going to go to the most significant bit here. Now what happens if I write least significant bit first? So if I want LSB first, so what is going to happen now? You can see that LSB is this part is has now received. You can see over here out 8 now gets the least significant bit. So what is the least significant bit? The least significant bit was 11110000. So 0 was the least significant bit, so that has reached the pin number 8, output 8. Alright, I hope you have understood the least significant bit and the most significant bit, and you have also understood what this pattern basically means. Why am I writing this pattern? Alright, so the commands are simple. You create a byte variable containing the pattern in binary form. You make the latch pin as low and you shift out in the shift out function. You supply the data pin, the clock pin, and whether you want the least significant bit first or the most significant bit first. That means however you want them to be displayed. Alright, and this is the variable containing the bits. And okay, this actually will shift everything into the shift register, but the output will not come till the data digital write happens. So when the digital write latch pin comma high happens, it actually gives a high to the latch pin, which moves the data from the shift register to the storage register, and the data is displayed on the LEDs. Let me explain a small thing to you before we finish. The output enable pin is actually connected to a low. So if it is connected to a low, the output is enabled. Now let me connect it to high and see what happens. I've connected it to a high, and let me make it a high also, so that it is a clear indicator that this is basically a connected to a high. Do you think output is enabled? Output is not enabled. Why? Because output is actually connected to a high now, so it will not be enabled. I have not changed anything in the code. And let us see what is the output of this program now. I've started the simulation. There is no output coming onto the LEDs. Why is there no output coming to the LEDs? Are we not writing the latch pin low or high and shift out and everything? We are doing everything, but we actually have not enabled it. Output has not been enabled. How do we enable it? By connecting it to a low. So when we connect it to a low, output is enabled, and it will give output onto the LEDs. So this is the working of the output enable pin. All right. I hope you have understood the basic principles of the working of the 74HC595. If you have any problems or if you have any suggestions, then please write in the comments, and do subscribe to this channel and do like this video. Thank you for watching. I'll see you in the next video.